All right, guys, we'll go ahead and kick it off. My name is Joseph Rodriguez. I'm an account executive with Elastic. I live in Austin, Texas. Before your stomach drops and jump out of here, and will not be talking any sales stuff today. This is purely for the community. This is for you guys to kind of collaborate and talk together, and also hear some amazing use cases that we have. So try to keep these things very collaborative and interactive, so you can ask as many questions as you want. Also, talking about some of the things maybe that you're doing as well, so more interaction is better for everybody here. If you do have any questions about anything that is kind of commercially related after the meetup, they are a good part of the talk later. But I'm really excited about the speakers today, because sometimes we do some things that are kind of a little bit more kind of feature or updates to versions related, but I think these use cases are going to be really, really interesting for everybody, and everybody's very engaged in talking about. So, first speaker is going to be Patrick Marlowe, who is he's the director of engineering, correct, with IPsoft, and he's going to be talking about Elastic Bots. And then we're also going to have Chris Carter from National Instruments, who's going to be talking about multi-tenancy as well. So, with that, I will go ahead and hand it off to Patrick.
Cool, thanks. So thanks for everyone showing up tonight and braving the weather. Thanks to National Instruments for hosting this, and also for Elastic kind of getting everything together. So my name is Patrick Marlowe. I'm the Director of Engineering and the Chief Cognitive Architect for IPsoft as a company. IPsoft creates an automation platform called IP Center. And we also have a cognitive virtual assistant called Amelia. You may be familiar with the concept of chatbots or virtual agents or things like that. And that's exactly what we do as a company. We've been around for about 2 decades. And we service most of the large, Fortune 500 enterprise clients in the United States, and also the Global 2000 kind of across the world. So one of the things that I definitely want to try to get across today, I would say there's really 4 main things I want to get across today. One is just talking about the use case that we build, obviously, around chatbots and around virtual assistants, but really the biggest piece is around measuring success around these things. So a lot of times businesses that invest in large technologies like this always want to know what happened to their investment. I just spent X millions of dollars on this particular piece of software. How do I know I'm getting an ROI? And not just how do I know am I getting an ROI? Show me. Like, where's the data? Where's the visualizations that say I'm actually getting this ROI? So that's one thing, measuring success. I'm going to talk about how we took all the data that we needed to take and how to prep it, because it doesn't come right out of the platform ready to go. We have to build ETLs and things like that to actually push it into Elasticsearch and let Kibana use it. I'm going to show how we can take that data and feed it back into the bot platform to improve performance, so building utterance pipelines. And then also I'm going to just show a lot of this live as well. On the live demo side, I totally like to live life on the edge. So one of the things that I'll be showing today is, we have an Elasticsearch on-prem deployment, but I've also been messing around with Elastic Cloud, and some of you, actually show of hands if anyone actually uses Elastic Cloud today. No? Couple? One? All right. So I'm just going to totally roll the dice on this one, and I'm going to deploy a live Elastic Cloud instance while I'm talking, and at the end of my talk, we're going to throw some data at it and see if it sticks. So that'll be fun. Right? Okay, cool. So a little bit about our project and the tools that we use in our project. So we are using Elasticsearch in Kibana 6.7.1, and there's a specific reason we are using that, and that's because the ETL that we built is using the Elasticsearch Pi library, which is only compatible with the 6.x framework of Elasticsearch. I know that 7.0 is out, and it's got some really cool stuff in it, but I can't use my Python ETL if it's not compatible with that version of Elasticsearch. So that's why we picked these particular versions of Elasticsearch Kibana to do what we're doing. We are also using the IPsoft bot platform, or a virtual assistant platform called Amelia. And then within the Amelia platform, there is a microservice called the metrics export service that we will be using to kind of pull all the data out and then shove it over to Elasticsearch. And we'll look at that in just a second here. So this is a key to tell me to go to the Elastic Cloud right now, and we'll start our deployment. And we'll let that deployment go while I'm actually talking. So let me just jump over there real quick, refresh. Also, thanks to the Elastic team for extending my trial period on Elastic Cloud so I could do this at the meetup tonight. So I'm just going to create a cloud deployment. For those of you who haven't used Elastic Cloud, it is the easiest thing in the world to use. I do not work for Elastic, nor am I a salesperson for them, but I do love this platform. It's really awesome. So we're just going to call this deployment Meetup, and I'm going to deploy this on GCP. I'll deploy this in the US Central region. I'm going to choose version 6.7.2, and even though our on-prem is 6.7.1, this is still compatible with 6.7.2 range. I'll leave the optimization alone for I/O, and then I'll go ahead and hit create deployment, and things are going to start moving and spinning in the background. So we're just going to let this run while I talk and do the presentation. We'll come back when this is done. It takes about somewhere between 7 and 10 minutes to get everything fully spun up. So let's go back to the preso. Let's see. Cool. So cloud's rolling. So let's talk about architecture and how we actually put this thing together. So there are really 4 major components that go into the architecture. So one of them is the Amelia platform that you see here. So the Amelia platform, as IPsoft deploys it, can be done in a single RPM VM deployment. It could be done in a clustered deployment environment. It could be done in Kubernetes, in the cloud, on-prem, off-prem, wherever you want to put it. The point is that box represents the application that we're going to be using from a bot or virtual agent perspective. The second piece is the Elasticsearch ETL tool that we built in Python using Elasticsearch Pi, which also is utilizing the metrics export microservice to extract information from the Amelia platform, flatten a bunch of data out, and then pipe it over to Elasticsearch, which is on your far right. So this is going to be our on-prem Elasticsearch, which I'll demo the most of tonight from, and then I'll also show how we can push that into a cloud version of inside of Elastic Cloud. And then on the far right, you really have just your domain expert or your SME that's going to be looking at the analytics that are being generated from Kibana. From a data pipeline perspective, the idea is that a user on the far left-hand side would have a conversation with the virtual agent. Messages will get exchanged. People's problems will get solved. Everyone will leave happy. A conversation gets closed. It gets written to a database. We have a cron that runs periodically that is kicking off the Python wrapper, which then goes and extracts the information, pulls it into the ETL, does some magic, pushes it over to Elasticsearch, and then we've already have some visualizations and dashboards built out in Elasticsearch, which we'll be able to actually look at the end of this particular demo. So measuring success, this is really the first big point. How do we know that we're getting an ROI from the things that we're investing our money in? So one of the biggest questions from the business, typically as we deploy these types of environments, for these large Fortune companies, are, am I getting what I spent my money on? And a lot of the times what they're looking at is really basic metrics like how many total conversations did I have, or what is the average handle time? Because what they're trying to do is compare these types of metrics and CSAT scores and net promoter scores and things like that against what their human agents do in the environment today. So did Patrick pick up the phone and did he do a first call resolution? Cool. That's one check for us, one tally mark. But the thing is, when it starts coming to bots and virtual agents, these types of metrics just aren't quite enough to understand where all the nuances and failures and optimizations live inside of the system. You want to be able to dive in a lot more granularly to see not only was PTO balance one of the top triggered intents or top triggered workflows for the bot, what happened inside of that workflow? Are there multiple branches? Are there multiple exit points? Are there multiple failure points? So we don't want to really consider everything a binary success. It either wasn't a success or it was a success. There is the idea of partial success, right? Maybe we were 33% accurate at doing what we did, but at least we tried to do something. So what we really need, and we're talking about beyond these core metrics, is a methodology or a way that we can dig deeper and look at more granular information in our bots. So we talk about an example of where this could go wrong in any environment. So when you think about a typical frequently asked question or an FAQ, we're typically trying to get from point A to point B. So that question might be something like, and I apologize for the small text here, that question might be something like, what color is the sky? Very, very simple question, right? There's a simple answer to it, and that answer might be blue. Now, the bot picked up on the intent, which was what color is the sky, and then the bot provided an answer, which was blue. But what happens if we ask the same question and the bot provides the answer red? The intent was still triggered appropriately, but the answer was wrong. So we can't say necessarily that our machine learning classifier had a problem. We want to say that our process had a problem. Maybe the content in that process, maybe one of the subsystems that the bot used, whether it was, AI markup language or social talk or whatever it is that was answering that triggered intent is where the problem lies. Now, if we're only looking at basic conversation metrics, we'll never see this granularity. Now, this gets even more complex when you start to think about enterprise level business processes. So on the screen, what you see here is just a snippet of a very large process, and this snippet of the process is actually to go out and search tickets within ServiceNow, if you're familiar with the ITSM suite ServiceNow. So when I say, hey, I need to look up a ticket in ServiceNow, there are many different ways that I can look up that ticket in ServiceNow. I can search by date. I can search by exact ticket number. I can search by keyword. I can search by owner. There are thousands of different combinations and variations and failure routes that can happen. So we need to be able to look at all the granularity between all the different paths and determine, were we successful? Were we fully successful? Were we partially successful? Et cetera, et cetera. So being able to tag our business processes allows us to get more granular metrics. Now, how do we do that? Well, we came up with a methodology called the Artificial Capability Equivalence Score, or ACE score. I know it's a mouthful. But ACE scoring is a really simple, ACE scoring is just like a really simple formula. So ACE score is equal to P over G, where P is the total performance of your bot, and G is the total amount of attempted goals, or intents, if you want to think about it from an intent perspective. So there are many different paths that you might be able to take if you're a bot asking, or if you're a human asking questions to a bot. Now, ultimately, what we're trying to achieve with ACE scoring is the ability to understand the bot's mastery of any particular thing that we have trained it. So if I'm training a bot to tell us what the color of the sky is when people ask that question, I want to know, are you 40 to 50% accurate, so you're only a beginner? Or are you over 80% accurate in doing these particular requests over and over again? So again, if we're using that example, if I say, what color is the sky? And the bot responds with blue, that would go down the path of trained performance. So trained meaning we did teach the bot to trigger that particular intent. And performance meaning not only did it trigger the intent, but the answer was also correct. So we're looking at the granularity of the path versus just a binary 0 and 1. But if I say, what color is the sky? And the bot responds with red, we still triggered an intent. We trained the bot to do that, but the bot failed to provide the correct answer. So that's a trained optimization. That's a tag that we can apply in the system that says, hey, human, please go look at this conversation because something happened here and we need to actually update the information for the bot so it performs better. Being able to tag this level of granularity, of course, with the ACE scoring methodology allows us to improve the performance of our bot more rapidly over time versus having to manually read through all of the chat transcripts and understand how our bot has been performing. So really the inception behind all of this came from IPsoft internally, where we were having to look at thousands upon hundreds of thousands of chats and try to understand where are all the failures happening, where are all the variances happening. And so building this out into a pipeline with Elasticsearch and Kibana has helped us to automate a lot of this tagging and also automate looking at the kind of top level metrics of what's happening in the environment. So now let's get to the conundrum that we had with our data. So you've probably heard of the phrase data rich, information poor. So from a chatbot or virtual agent perspective, we were really data rich. Now, I know this is like a cardinal sin showing code in a presentation, but don't worry about the code. What I really want to talk about is the structure of what we're looking at. So when we export a conversation from the Amelia platform, it comes out in a JSON object. Now, JSON objects are awesome because we can pack a lot of information into them, and we can look at relationships between that information. But one of the problems with JSON objects sometimes is that they have nested objects inside of them. So for instance, everything that I'm highlighting in red on the screen right now is an individual utterance coming from either the user or the virtual agent. So the very top box, the utterance says, "Hi, I'm Amelia, and I'll be your service desk agent." The second one says, "How can I help you?" And the third one says, "I need the status of an expense report." So that was the bot greeting us, and then the user saying, "I need the status of an expense report." But you'll see that there's a lot of great metadata that exists inside of these boxes. And we want to be able to build visualizations and look at aggregations of that metadata, but it's inside of a nested object. And even more so, some of these nested objects have nested objects themselves that refer to other portions of the overarching conversation object. But guess what doesn't like nested objects? Our friend Kibana, right? Kibana does not like nested objects. And nested objects don't play well with aggregations. Nested objects don't play well with looping queries. So we can't really do anything with the data that lives inside of the nested objects. Now, when you're doing hundreds and thousands and hundreds of thousands and millions of conversations and chats, that means you're going to have a lot of nested objects. And that means that Kibana is not going to be a friend with those nested objects. So how did we solve that? We didn't just abandon the Elasticsearch project, and we didn't just abandon Kibana because we said, there's got to be a way to figure this out, right? And so how did we figure it out? We said we need to take all that data and we need to flip it on its head, and we need to flatten it out so we can search it appropriately. So talking about the structure of the data as it came out of the bot system, we had a hierarchy in our JSON object where there was a conversation. That conversation had some top-level metadata that was a part of it, and then it had a lot of nested objects inside of it. And some of those nested objects had nested objects themselves. Now, if you think about this from an Elasticsearch perspective, this conversation existed as one document, right? This one document, we were able to extract the top-level data out of it to make fields that we could then perform aggregations on. But what we lost was all of the nested objects. We weren't able to actually perform any sort of meaningful analytics or aggregations or visualizations on the nested objects. So what we had to do is actually flip all this on its head, start over, and said, what if we took, instead of the conversation as the center of the universe, we flipped this all around and we said that the utterance was the center of the universe? And what if we could take each utterance and extract it from the conversation and instead embed the conversation metadata in each individual utterance? So when you're looking at an utterance, you know where that utterance belongs. You know it belongs with this particular timestamp. You know it belongs with this particular conversation and all of the information that is associated with it. So when you look at it from an Elasticsearch perspective, that now becomes 4 individual documents inside of Elasticsearch and 1 unique conversation. This then gives us the ability to take both the conversation metadata and the embedded utterance metadata, since they are now all top-level fields, and extract those into Elasticsearch to become aggregatable fields and fields that we can build visualizations off of. Now, one of the questions always is, what happens with the fact that you're duplicating all of this conversation metadata and each of these utterances? It doesn't really matter, because in Kibana, you can do unique counts and you can do a lot of unique filtering. So you never have to run into that from a visualization perspective. You're just creating a document per utterance. Okay, so let me show you what that actually looks like in real life. So what I'll go through first is actually what the dashboards look like. And we'll kind of talk about the dashboards themselves, and then we'll kind of do a live chat demo and then push some data out there and see what happens. And then we'll come back to Elastic Cloud and see if we can break it or not. Okay. So from a dashboard perspective, I'm going to refresh some of this information. Let me filter this down so we're looking at a big old chunk. So from a dashboard perspective, one of the things that we were building, should I zoom in here so you guys can see this more? One of the things that we built out is just kind of the top level metrics that I was referring to, at the beginning of the conversation, the talk, where I'm saying, we've got things like total numbers of conversations, average handle time of these conversations, the top Amelia instances where we're extracting this data from, all the different domains and looking at conversations within a domain over time. But we're also pulling data out like what are the top triggered intents, what were the executed BPN paths, so what are the business processes that were executed over time, what entities are we extracting in these conversations, and then also starting to pull in things like utterance, like word clouds and utterance heat maps. So what are the words that people use most often, and are we building our utterance pipeline and our classifiers appropriately to pick up things like triggering an intent when someone says, oh, actually, I need the status of an expense report first, or it's about the printer, or, I need guest Wi-Fi, or whatever those particular things are. So this is more of a top-level dashboard that you would, most likely see in a typical kind of chatbot environment. I also have a aggregation or visualization that I built up here called the average ACE score, which we'll get into on the next dashboard. So when we started talking about ACE scores, and I was talking about tagging this data, I know this is going to be difficult for you to see. Or actually, should I zoom in here more, or how bad is that? Fine? Good? Thumbs up? Okay. So when we're talking about ACE scores inside of conversations, what we're really looking for is how many times did a user ask for a particular thing that they wanted, and then how well did the bot perform at doing that particular thing. Now, in a typical kind of like chatbot environment, you may think of these as like single shot asks. So, for instance, if talking to Google Home or talking to Alexa at home, you're going to ask a question, a response is going to come back. More recently, you're able to actually do follow-up questions, which are good, and they're kind of contextually aware. But in a platform like Amelia, conversations can go on for a long, long time, 60, 70, 80, 90 utterances as you're going through all of the different business processes and extracting information and clicking buttons and doing drop downs. You're continuing to have a conversation with Amelia the same way that you would as a human. So because of that, you might have lots of different interactions in a single conversation. So we don't want to just say that this conversation was good or bad. We want to say every single interaction within that conversation, what happened? Was she successful at the first 3, but she failed at the last 2? That means she was 3 out of 5, whatever that percentage, I can't do division right now. Let's do 3 out of 4. She was 75% correct, right? So what we're able to do is actually take things like an individual conversation ID, filter down to see what that conversation is, and just a nicer interface versus looking at this in the JSON array or in an Excel spreadsheet or something like that. Look at what the user and Amelia were talking about. So what's my vacation balance? Triggered the intent called PTO balance. You have 17 vacation days left. Do you want some time off? Yes, please. When do you want to start? Oh, actually, I need the status of a ticket. So I can quickly see here that ticket status, sorry about that, that ticket status was a secondary trigger within this conversation. And so now what I can do is really granularly track every single interaction that is happening inside of this conversation. And I can say, how many attempted goals did we have? We had 4 attempted goals, and we had 4 trained performance. So she was able to successfully do each one of these goals. So her ACE score was P over G, 4 divided by 4, 100%. Now, a lot of the conversations that you're going to see in here are going to be 100% because we're doing a lot of conversational regression testing. So I'm just throwing conversations at the instance over and over again that I already know are going to be successful. So that's why they're coming out with 100% tagging. But in a production environment, when we're looking at live client data, the ACE score number is obviously going to vary depending on the intents that are triggered, the times of day, the days of week, the domains of information that we have trained Amelia to do in that particular instance, and just kind of depending on how you're slicing things up. So one of the last dashboards that we built out, and this was more recently, was the idea behind extracting utterances that were failures. So things that Amelia was unable to pick up. Let me filter the time range down here again. Sorry. So utterances that did not trigger an intent. So utterances that maybe triggered another subservice like AI markup language responded versus an actual triggered intent, or social talk responded versus a triggered intent, or our chit-chat responder or EQA responder. So there's about 25 different subsystems within the Amelia framework that all run through a logic net to decide which subsystem is going to respond to the utterance that comes from the user. So typically, like I showed you before, we have a lot of different kind of business process links. There are many other subsystems that can respond. So if a subsystem responds that is not a business process and not a triggered intent, we want to know who responded and what did you say back to the user, right? So if I say something like, actually, let me filter this down to the Alexa domain, because we have a hardware integration with Alexa. So these are always really fun, because when you're talking to Alexa, you're relying on the hardware speech to text that Alexa box is doing. And sometimes the words that it thinks that it hears are not exactly the right thing. So you can see, just a bunch of random stuff on here. No, thank you. TAY. Are you wearing clothes? That's definitely a weird question to ask a bot here. Yeah, lots of crazy randomness going into Alexa. So the thing is that these utterances are going to the Alexa box. They're going through an Amazon Lambda and then being sent over to Amelia, who's then trying to respond based on the text payload that's coming in. So we want to see what Amelia is responding with. So what do you do? E, I wear multiple hats, but generally speaking, I'm a cognitive knowledge worker. So that came from the social talk responder. And we say, okay, is that something that we should probably build into an intent-based response so we can then take that and drive it into a business process? Because if the answer to that is yes, then we want to actually extract a lot of these responses and utterances from this view inside of Kibana and feed them back into the platform so that we can build out our classifier model, improve that machine learning model so that we can trigger these particular types of events when they happen. So let me go ahead and actually have a conversation with our crazy virtual assistant, Amelia, here. And I'm going to keep her muted. There's no reason to listen to her talk. Hey, what's up? So I ask her, hey, what's up? And she says, I am chatting with people on the net, as she does. She watches cat videos sometimes as well. I need to open a new ticket. So this utterance is actually going to trigger an intent in our classifier model. So let me zoom, actually not zoom in here. So this has triggered an intent in our classifier model to actually go through a process called create a ticket. This is actually hitting a ServiceNow instance as well. So she's saying, can you give me a ticket short description? So I'll say this is a test for the Elastic Meetup group. She's going to go ahead and take that in as the subject of the ticket. She's created an incident number here for me. She's marked it as medium. She's asking me if I want to go ahead and escalate it. I'll say no. And that's going to be the end of that really short interaction. Now, what we're going to be able to see in the logs, I know this is going to be really difficult for everyone to see here, is that in the microservice of the metrics that I'm storing inside of Amelia, I've created this concept of an interaction. Now, the interaction has some metadata that is inside of it, like the intent, which was add a new ticket, what the score of that interaction was. So since we just completed it, that interaction is trained performance or fully successful, 100%. And also another tag called abandoned, where we can look to see if the user chose to jump out of that interaction at any particular time. So for example, if I continue this conversation and say, I want to take some time off, this will trigger another intent called PTO request. And now before I continue, I can actually look at the interactions array, and it's being built out. We now have a second interaction that is being built out in the string. And right now the intent is triggered as PTO request. The score is still set as trained performance. But the abandon flag is set to true, and that's because we haven't actually gotten to the end of this interaction yet. So she's asking me when I want to start, and I'm going to say something terrible like, you are a terrible person. And then she's going to say, that's not what I want to hear. I want to hear a date, and I'm going to say, I don't want to talk to you. And then she's going to ask, do you want me to get you to support? And I'll say yes, right? Which is actually going to trigger our escalation service, and that'll go into a conversation queue where it will sit for a human to actually pick up that conversation and then go back and forth with me. But what's happened in our interactions array now is that I've chosen to abandon some of these interactions because I don't want to talk to the bot anymore. And so what we're going to do is we've already automatically tagged that the user voluntarily jumped out of these interactions. So what happens when this conversation is actually closed, and I'll close the conversation and end everything here. This is getting written to the database on the Amelia side. Now in a production environment, when the cron runs or when I can manually kick off our Python wrapper, it will go out, extract these metrics from the service, push them into Elasticsearch, and then they appear on our dashboards. So then I can actually go look and see all the things that we were talking about and our interactions. So let's go and manually run some of this and see what happens. Is this the right? Sure, let's do it. Let me log in. So this will take a couple of minutes to pull down all the information. So it's exporting 371 conversations from the domain employee services, which is the domain I'm having all this information or these conversations in. So that's going to take a second. It's going to write it to the dashboard, and we'll come back to that in just a second, and we'll see what happened there. So let's go and check on our Elastic Cloud deployment. It's not looking healthy. So we've got Elastic deployed, no Kibana instances are running, which is definitely bad, and no APM instances are running. So technically, since Elastic is up, I can send data to it, which can't look at it. So I'll go ahead and show you how mostly easy this is to do. I'm going to reset the password information so I can actually log in. So I have just a real simple file that I've made to take this information from the new instance that it generated and throw it in here really fast. Save it. And then let's push some data out there. So I think Kibana is actually up and running now, which is good. Let's launch it. Let's make sure we can log into it. Cool. All right. So that happened really great, really fast. So now let's push some data. So we've got some data going into our on-prem instance. Let's push some data into our cloud instance. And then that will conclude things. So cross our fingers. Hopefully this works. As long as it doesn't throw any errors at me, it's working. Cool. So while that's running in the background, again, we can. How am I doing on time? About 5 minutes left. Good. Okay. Cool. Cool. It looks like it's doing its thing. It's awesome. So, funny story. As I was preparing for my speech this afternoon, I was sitting at Starbucks in the domain and furiously putting together some different animations in my slides and making sure that all the logos look nice and neat. And as I was pushing data over to my Elasticsearch on-prem cluster, I was sitting over here in the DevTools window, and I have a bunch of console commands sitting there in my on-prem instance, and I wasn't paying attention, and yes, you know what I did. I went and deleted about a year's worth of data. I deleted every single index that I had, because not only did I do a delete on an index, I did an Amelia star delete and deleted every single index. So I'm sure the Elasticsearch veterans in here will obviously laugh because I didn't have that backed up, but it didn't matter because it's a dev environment, no big deal. So I did have to spend some time prior to coming here, and actually after I got here, repopulating that index so I could actually show you something on the screen. So word to the wise, make sure that you are paying attention when you are looking at whether or not you're doing a git or a put in the DevTools environment. So I can see the indices being populated now. So I can see Amelia Demo US, which is being created. I can see documents are now being written here. Remember, this is my Elastic Cloud environment. If I go to Discover, oh yeah, I haven't created an index pattern, so let's make one real quick. Amelia star, next step, created, create index pattern. And let's go to Discover. And let's look at data in the last 30 days. Cool. And now we have data in the cloud. So now it's really simple from here. Obviously, you know the rest. To actually build out visualizations, we can do really easy things like go and select our index pattern. And of course, since I'm duplicating some information, I want to do unique counts of conversation IDs. And let's go ahead and make this a date histogram. And let's zoom in here. Oops. So you can see that data is now flowing into our Elasticsearch Cloud instance, and we're getting all the fun stuff that we were just talking about. So with that concludes my my presentation today. Again, the main thing was really just to show you how we can take data from a bot like Amelia. This could be Dialogflow. This could be Azure Bot Framework. This could be Core.ai. Pick any bot framework that's out there. You're going to be able to extract data from it in a similar manner. It may not be a full JSON object. It may be partial objects that you'll have to piece together. But being able to search and look at all this data in Elasticsearch and visualize it with Kibana is something that we built internally. And so thanks to my team that's also helped me a lot with this. Some of the guys are here tonight. So I'll open it up for questions or anything else anything you want me to go back and cover or talk about at all? Back here, yeah.
It seems like a fun system to prank people with, like the system, like, they hold for an hour while I'll off the watch.
Oh, yeah. Absolutely can do. You have a question?
What's the process?
Behind these process maps? The underlying technology is called Camunda. Camunda. So the top level, so that's the actually base core technology is called Camunda. The iteration, or I guess the fork that we're using is called bpmn.io. It's bpmn.io version 2. So it actually allows us to, for instance, if I want to actually build a business process out, and where I'm doing all this tagging that then gets extracted into Elasticsearch, that's all done in this. It's really just kind of like a drag and drop framework. So if I want to build a new, node, I can, just simply add a new node here, say hello world. And then in that node, save that, and now it's part of something that the bot will do. You can also do a lot more powerful stuff besides just explicitly telling the bot what to do. You can say, look for entity extractions, trigger these intents, run these other workflows, go down crazy, crazy paths. Cool. Yes, sir. Mm-hmm. Yeah, so it's the exact same way. So we have Amelia today integrated with a lot of major contact centers. So think about UCCE from Cisco's perspective, or Genesis IVR, a lot of the actual chat contact centers like LiveEngage and stuff like that we're also integrated with. But from a voice perspective, it's no different. So the initial interaction will be over the phone. I'll make a phone call. It will hit UCCE. There will be a SIP negotiation that happens between UCCE and an Amelia voice gateway where we're actually connecting those two pieces of information. Once those are connected, though, all the business processes, all the NLP, all the machine learning, all that stuff that's happening behind the scenes is the exact same stuff that you see here. The only difference is that we're now exchanging payloads via voice. So we're doing speech to text to incoming, and we're doing text to speech outgoing, but the brains behind everything is still the same platform you see here. Yes. Correct. No, not at all. Well, I mean, I guess you could, but I don't know that you would want to. Yeah. I'm not aware of. I mean, I don't think that Elasticsearch does any translation services or anything like that. So, okay. Yeah, but I mean, we have actually in the setup that we have here, we do have, I mean, for instance, I showed you the Alexa environment. We do have another environment that is a voice environment for banking, where users can actually call into the phone and have conversations with Amelia, and we're actually collecting all that information here as well. Cool. Any other questions? Yes, sir. Mm-hmm. Yeah. So that's actually one of the cool things is like typically if you're like grabbing logs and you would have to install like metric beat or file beat or something like that on the server itself. So with the Python library, it's actually super easy to set up. It's really just negotiating a connection between whatever your environment is that you're running Python in and with your Elasticsearch server. So if you noticed when I had this file up, the really basic information that you need is like your username and password for the instance, your instance name, and then the port number. You can also do OAuth through it and use tokens and stuff like that, or you can just do basic authorization or authentication as well. So it's just a broker, really. And then it allows for like things like creating indices, deleting indices, writing into them, things like that. Yeah. We're batching them in. So one of the things that just from a load perspective, we wanted to actually have conversations happen in real time for a while, let's say 15 minutes. Then a cron will run and sweep back, 15 or 20 minutes to actually grab all that data and pipe it in. So we could run it in real time if we wanted to. We could just have this thing like constantly pulling data in. But we don't want to hit the Amelia server over and over and over constantly. We could have done this the other way. We could have said that as soon as it hits the database, we push it instead of pull it. We just decided to go with the pull method. So, anyone else? Anything else? Good? Cool. All right. Thanks, everyone.
Great, I appreciate it, Patrick. That was awesome.
Yeah.
I've come to a lot of these things, and that one was definitely a new one for me. So yeah. I definitely appreciate it. That was very interesting.
Yeah, it definitely. I don't know how many people are like using Elasticsearch to do chatbot stuff. So that's why I thought it was interesting. I did as I was researching actually to find out if any other people have been doing stuff like this. I did find people that were actually trying to build a chatbot in Elasticsearch, like using Elasticsearch to provide the responses back for chatbots, which sounded a little wonky, but interesting. Cool stuff.
No, that was great. I really appreciate it. Thank you. So next up, we got Chris Carter, right? So how am I supposed to intro you? Do we go with Galactic Overboard? Okay, that's what you are at National Instruments. So that or Dr. P-Funk. I don't know if we're...
Yeah.
Okay.
Thank you.
And then we also have Cy Jury. So I was remiss in not thanking these folks for putting us up here. So I'd really like to say thank you for hosting us here. It's a fantastic location. It's been amazing. So thank you very much for putting us together. So I'll pass it over to you, and you can do the intros. And
my name is Cy Jury. I'm an IT manager here at National Instruments. My team manages, for their system administrators, we manage about 45 different platforms, all internal, third-party applications mostly. And the decision was made last year to take an instance that our InfoSec team was running of Elastic, and we would eventually own that, but we were going to redeploy with more of the enterprise in mind. Their deployment was set up to really serve their needs. And there was a couple other teams that didn't piggyback on that, but they weren't set up nor qualified, not the right word, ready to provide enterprise support for a new cluster. So we were tasked with deploying a new cluster and architecting it for the enterprise and keeping everyone safe from everyone else, but providing access for anyone and everyone that they want to leverage it. This is Chris. I'll give it up to him. He'll do most of the driving and talking.
Yeah, so we're talking about multi-tenancy at National Instruments. The big goal here was to provide the ability for really any team that wanted to use our Elk instance to really get on board and really provide a path that was guardrails, not gates, to really let them use the system, go down the path without having to involve us and really annoy us with a whole bunch of questions, let's be honest. So really it was about empowerment to these end users that we have never met, that we could kind of point them maybe to a wiki page or something like that and really get them on board. And so really this is talking about the framework that we went down to get them in our system. Before I go too far, I did want to talk about what our architecture looks like, just so you have some ideas. So we have a hot node cluster. It's basically 3 Kibana instances, 3 Logstash instances, and 3 hot nodes of Elasticsearch. And then off to the right, we have our cold and warm clusters that are basically 2 nodes in warm, 2 nodes in cold, and we basically shove data through the ILM process, which is Index Lifecycle Management, and into those other nodes. It's a great way to kind of handle this idea. We don't know all the data that's coming in, and it lets us handle situations where if someone tries to overrun us with data, we have plenty of storage to shove them down into lower tiers. We have all solid state in the main hot tier, and then slower spinny disk off to the right. Again, this is just to make sure no one overruns us, and each of those cold nodes have 5.6 terabytes of space, so we actually have over 25 terabytes of raw capacity. So as we start to reach out to these people, or they reach out to us more or less to start getting involved, the first thing we need to know is what kind of data they want to ingest and really understand that data. This really helps to drive like how we will do retention policies, and actually going back to the previous slide was, are they going to overrun us? And that's really important. Here in this phase, we'll define like what does their data look like, the retention policies, and really everything we need to get them on board.
I wanted to add too, so the retention policies, we have different teams, different use cases. We have compliance data that we're ingesting. Yep. We have data that's coming from NI.com that they may not need it for more than a week. Compliance data, we have to retain it for longer, so this is the way that we're designing for the.
Right. So next, after we've kind of defined their data and really built out their grok filter, or really how they want to massage this data to make use of it, we have a wiki page that has full detailed instructions on how to install FileBeat. Any of you have ever installed FileBeat? It's very simple. You're just unzipping and basically importing. We provide a sample template that they import into their FileBeat, and that gets them going and up and started. A big thing of this is to set up the proper tags. I'll go into tags a little more, but the key thing here is teams are responsible for their own FileBeats, and then they'll just start sending data to us. So I talked about tags. What are they? They're actually a piece, an element of Elasticsearch. They're built into FileBeats, and they're kind of pre-built, ready to use. We take that a step farther and actually use them on our Logstash side. And I think this is probably one of the bigger things that we did to handle multi-tenancy was getting these tags set up and getting them for 1 tag per team, as well as the type of log that they're ingesting. So a good example is we have a web systems team that handles our ni.com, our main website. And so they're going to be pulling in Apache logs, HA proxy logs, and all those different logs have different grok patterns or different needs. And so because of that, we have various tags that we can apply. So what does that look like? We actually have a pretty gnarly pipeline. It's about 2,000 lines of basically just if statements that are, saying if this tag exists and is this, then we will go ahead and put that in the proper index. You can also use tags on the input side because not all of our clients are using file beats. Some of them are actually sending us raw UDP traffic or even syslog traffic. We can actually tag at that beginning input level. And that's very important because we will then go down to the conditional filter part of Logstash pipelines and actually perform the grok pattern we need, the KV filter, really whatever kind of filtering they needed. And then at the very end, we actually use those, again, the same tags to define what index pattern gets created for them. And let's say that someone actually ignores all of us and doesn't put a flag or put a tag, we actually have a catch-all bucket at the very bottom that says if they didn't use any tags and just ignored what we needed them to do, we'll go in a catch-all bucket that we monitor. And we go ahead and set alerts up off that, and we can follow up with that user and say, hey, we noticed you were ingesting data, but you're not doing anything with it correctly. We'll catch up with the user and get them in the right place.
Drawback. Single.
Oh, yes. There is somewhat of a drawback here is that when you have a lot of pipelines, so let's say that, for our team, we have about 20 examples of different logs and different ingestion styles. And because of that, you have a lot of cooks that are all in this environment, all working, making their own groks. And so you can, if someone makes a bad mistake, can actually bring down the entire pipeline. Can and did. But we've actually, and even the tool does a good job of rolling back to the previous working pipeline, as long as it's not a major mistake. So the tool has a good kind of failback on that. So index naming conventions, this has to do with index patterns, and really it just has to do with, for the Windows team, we make them their index Windows dash. For the Unix team, it's Unix dash. For our team, ASMT, it's ASMT dash. It's very basic. But the idea is that you want teams to be able to look across other people's indexes, but at the same time, they need to be able to pull up and look at just their indexes right away. And so that's why the Windows team can look at everything that they've ingested. Our team can look at everything they've ingested, and it keeps everything kind of segmented. Now, of course, we're ingesting Apache logs, and so is our other teams. So you can actually make an index pattern that was just Apache logs, assuming you wanted to see that cross-correlation. The way we use the system is not really like that, then that you would pull up all of our data because it's just so spread out from, you might have business intelligence systems to domain controllers to ni.com, which is externally facing and has really little to do with internal. But it gives you that flexibility. And that's really what we wanted to provide was flexibility, not so much why you would want to do it, but if you wanted to do it, we'll let you. So the index patterns, I think y'all know about them. They're just optional wildcards that you present up and really make it simple to look at all of one version, all of one team's logs at a time. So how this is tied together is really as data comes in from the top, which is like a file beat or any kind of beats, the data is already tagged. It comes in through our Logstash pipeline, through the if statements, conditional filtering, and finally makes it to the index of our choice. Fields. We've also decided to use fields in our environment. Fields are nice because they're optional and really let people add additional content to their data without really overloading anything else. They don't need to talk to us first because you can just add them into the pipeline. And they do things like dev versus prod and just really as a logical separator of their own data. We really wanted to empower them to add them as they wished, but really not have to mess with us because they won't impact any of the index destinations or even the ingestion. All right, and then spaces. Spaces really help to kind of tie all this multi-tenancy around. So in version 6.5, they introduced the new spaces feature, and it really just lets you organize all the objects that exist in the system into their own little areas. Also, objects can be imported and exported between spaces, which is actually a really important feature. If someone develops something cool, they can go ahead and look at it. Well, if they make something cool, you can import it into your own space. So here's an example of what we have at National Instruments. The big thing that I like to call out is like the free space. We have a free space that anyone can go in and just make whatever they want. They have full admin access to that, and it's really a safe space where people can try stuff out and do cool things, versus your normal space, which are the team spaces below, are really meant more for your production dashboards and things that are you want to show and look at once or twice, but repetitively. Another important thing is spaces are in the URL, so you always know where you're at, and you can also look in the bottom left and see where your space is. Because sometimes we have had users that get lost and they aren't in their own space, and they think everything is missing. All right, another thing that really helped to kind of tie all this together was the central pipeline management. This was a feature that was, and I forgot what version it was added in, but it's a relatively newer feature. And it basically lets you manage your pipeline, getting it out from the file system level, and lets you get it into more of the GUI. You do all your edits in the GUI, and it saves it, and it actually shows you, how many events are coming in, and it's very, very useful. And the big thing is it lets you edit the pipeline without any downtime to your ingestion. We also have, in use cases, multiple pipelines. And this is so you can tune them separately. Okay, another thing we have is role mapping and LDAP. So by default, everyone has their own space that they're a part of, and with that, you get full admin access, and that's built off of a team group. I am sure most of y'all companies have a group that your team is a part of, and so we're just automatically adding all those users to that team to their own space. So Windows admin, first day on the job, logs in, he'll automatically have access to his own Windows space, as well as the ability to create stuff. So it's really just people that didn't even know they have access are joining, starting with access, and ready to go. No provisioning, no reaching out to us. Another thing we did was make sure that you have read access to everyone else's space. I don't think we have any sensitive data today, but no, it's just
compliance data is not sensitive. It's compliance related data, so it's safe for everyone to have access.
Yep. But then our role access is mapped through LDAP groups back to their various roles, and so each one can get in the system and do what they need without really bothering anyone. All right, so our future roadmap and really things that we're looking forward to testing on is around central beats management. This would kind of solve the one step of we have all these teams coming to us and they're installing their own file beats, which is great. And really we did that more of a time and resource perspective because we just don't have time to go out there and install it to all these machines. But central beats management would let us kind of bridge that gap of maintenance going forward so they don't have to maintain their own version, things like that. And we're really looking forward to testing that out more. Also, upgrade to 7.x. There's some new features in there that we're looking forward to, mainly around solidifying index lifecycle management as well as the new cluster migration stuff that should help with performance. And finally, expanding the system to non-IT teams. This is kind of a personal struggle at NI in that IT teams are very off on their own and rarely interact with our business side. But just recently in the last year, we've seen a lot of great strides on breaking down those walls and really getting everyone on the same systems. Because I think when we started this journey, we found out relatively quick, R&D already has an instance of Elasticsearch that was up and running, but had overloaded theirself with too much data really quick on spinny drives and didn't really plan for what it would look like once you have 12 terabytes on a desktop system loaded up. So it's really kind of breaking down those walls and providing an IT supported system that's in a data center that actually has people checking on it.
Yeah, up to this point, it's been primarily used for, and that includes Splunk and Elastic, which we're migrating all into Elastic. Primarily just log aggregation, upward searching and alerting and things like that, but no real business use cases. So this is an opportunity for us to expand it out, get continued investment in things for the growth.
Yep. Does anyone have any questions? Yeah.
Are you letting users get their own pipelines?
So we do have kind of some power users that we've empowered to do that. We go off and make their role special. But generally what we're doing is we're getting them the pipeline debugger, which is built into the dev tools, or the Grok debugger, sorry, and letting them build their own Grok. And just letting them go wild. The documentation's already pretty good for how to get started with a Grok filter. It starts with just like a one-line log, and it shows you how to grok it out to something useful. And once you kind of expand on those use cases, eventually anyone we found has been good enough to get a working grok filter. Once they get it, it's just copy and pasting it into our environment. But we do have several power users so we have a follow the sun model with 3 sites. And so we have people in Penang that need to be able to edit the pipeline. I don't want to wake up in the middle of the night. So we've empowered those people to edit it on their own.
Yeah, the goal as we continue to expand this is to build services that continue to reduce the amount of interaction in the workforce, forcing people into, making it more self-serve. We are still in the process of building this thing, still in the process of deploying it, so that's kind of one of the features.
Yep. And one caveat to that is we have had some users that were a bit reckless with their pipelines, so we actually broke their pipeline off, let them do whatever they want, break it, do whatever. It won't affect the other pipelines. And so yeah. 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 Run around 30, maybe 45.
That's the basic set of users, but then there's, as we're migrating away from Splunk, there is a set of business users over there. Basically, a lot of our NI.com types of analysts are doing a lot of reporting and searching. So I'm not even sure what that number is, but it's not enough, and that's why we're pushing it on.
Yeah. The more people we can get on it without having to handhold them to success, and the tool actually has so much overlap with other platforms that we've bought and barely use. So it kind of just like, hey guys, you should continue to try to use this, and we will provide a little bit of handholding to get you going, but ultimately people are being successful on their own.
Just on your architecture side, I see that far left, are you investing in from I see that? You also mentioned that Windows network where it's all the beats on up there, getting monitoring again.
So we are actually using Ichinga to monitor the suite. That's not to say that Elk doesn't do a good job of monitoring. It's just, as our application team, we have years and years of experience with Ichinga as an already existing platform that we have set up to on-call rotation and things like that. And so ultimately it's kind of, we're not ingesting data, it is ingesting from us. So
that's a big request from a lot of the other infrastructure and operations team, is allowing them to be able to correlate that monitoring data and alerting data with the other data.
Yeah, we have a bit of a tools problem. We have a lot of tools that do a lot of things, and Elk is one of the recent ones we've got into that has so much overlap in all these tools. It makes you think, like, why did we buy that? Because now we got this, but it's hard just to close shop on one thing and migrate over, especially when you're talking about production alerting. Yeah.
Looks like you must be on a pretty recent version.
Yes. Yeah, we've been chasing versions pretty much since we got started, just the new functionality. We get excited and in beta, which, this is for me, it was a new application that has beta features that ship. Normally it's like the beta features ship, but they don't even tell you that. They just don't work. So it was nice to see that, but we would use them and then be like, okay, now we need to leverage it. So yeah, we're on 6.7.1 right now.
Yeah, we haven't really started, or we had just started going kind of hardcore at this deployment only for about the last 5 or 6 months. So before that, it was a lot of planning, a lot of playing, a lot of failing. But over the last few months, we've been put on the gas.
Yeah, and speaking on that, we're actually using I didn't have that in our architecture slide, but we're a full Docker install. And so upgrades are actually as simple as versioning up that text file and turning it back on. So we spend more time waiting for the nodes to balance out during an upgrade than we do on the upgrade itself, because those are fast. And rollback is simple too.
We will have at least one cloud instance at one time. When we were doing the planning for this last year, our Cloud Center of Excellence team was just forming and had direction, but nothing concrete to say these are going to be our needs for 2019, 2020, 2021. So we're holding off, but we already know that the demand's out there. We've had many teams come to us that are moving a lot of their development to the cloud. So yes, it's a demand and it's something we'll have to meet.
But for actual training instances, we use Docker. So we'll have they have really good instructions on their wiki on how to use Docker, and it's just a basic 2-node cluster. It turns on real fast, and you're up and running in a moment. Works on Windows, Mac, Linux. So a lot of people are enjoying that.
And we have some use cases where folks might need to restore or take their data offline from the production instance. So we've made it very easy for them to deploy their own locally, pull in whatever data they want, tear it down whenever they want, and they don't have to worry about any kind of restore process.
Yeah. Any other questions?
So out of curiosity, are some people relatively new to Elastic during the room today, or are they seeing better, seeing the best there? I'm pretty successful. I mean, that's for sure. So I think one of the things that's been fun to watch is that you guys haven't been on this very long, and that journey that you've had on through. We've been talking about positive history. I think for some people that have just come on, like kind of understanding you guys have gone a really long way in a short amount of time. Really going fast. Yeah, going fast, doing a lot of work. But you've only been doing that for several months. You guys have really, so I mean, if you could kind of describe that, going through the documentation, you're great about reading everything.
Yeah.
Telling us something we didn't know for
Yeah, I definitely suggest reading. Wiki is about one of the better ones I've seen. Just start with a good Google search, and you normally always can find the page that you need to get to. I will say one caveat is make sure you're looking at the right version, because it's very good on having all the versions there, and sometimes you'll be on current and you're not, and you're reading stuff that's really cool, and you can't use it. But ultimately, like, you use the resources that are out there. They have great little tutorials on most anything you're trying to do, and the dev tools are actually really cool. From the grok filter and the search profiler, things like that.
Yeah, the other thing that we did to accelerate the build out was, as regular infrastructure admins, we don't get an opportunity to be agile very often, and so we took this opportunity because it was a ground up learning experience to actually take an agile approach and make fast progress on a daily basis. Also fail a lot, but fail fast and then forward. So that's been a cool learning experience for us, and something that we're looking at adopting for other instances where it makes sense.
Yeah.
Did the experiences of your R&D group that have used Elasticsearch help any, or just learn what not to do, or?
That one was an easy what not to do.
Yeah, that was just
2 6 terabyte spinning disks is not a good configuration for your local storage. Yeah.
Yeah.
So they actually can't use it very well right now because of the decisions that were made by other teams years back. So that is one of our goals, is to get them onboarded, or at least get them into a state where they can manage their own deployment and know that it's done for best practice.
Yeah, and then we do have our other instance that's another team was managing an instance. It's on 5.6 or something. That instance was managed well for what it was, but ultimately didn't have the manpower to make it useful. And I think nothing against them. It was just that's where they were. They were kind of in just keep it going mode. They never really have the time to look a little ahead, and our team specializes more in that look ahead. And so we're able to kind of take upgrades, more rapid upgrades, and really take on the feature sets, whereas they were just really saying, okay, I can only ingest this compliance data, and like almost every day they would look at how much data do I have? Oh, I don't have enough to make it to the end of the night, and they would just delete stuff and then restore like exactly what they needed for that next day. And so like that's a use case we didn't want to be a part of, and so that's why ours is architected in a better way.
And it really, they built their instance out for their usage. It wasn't done to allow other teams to be onboarded, and so it really is nothing against them. They used it for what they needed it for. They manage it well, but it's not architected to allow for multiple teams.
Yeah. Honestly, the biggest surprise that we've gotten from users is how much faster it is. We haven't done a whole lot of tuning. They have tuning guides on kind of recommended for RAM, and we worked a little bit with support to get a sizing guide set up. But honestly, there's not a whole lot of tuning that we had to do. As long, we gave it the resources that they said we needed, and it ended up working really well.
We'll check back in another 6 months.
Yeah, we'll check back, but we do have around 7 terabytes of data loaded up, and it's remarkably quick for what it is.
What's our daily ingestion?
So our daily ingestions are right around 400 to 500 gigs a day.
Actually, that doesn't even include the duration security, so we're probably at a terabyte.
Yeah, maybe a terabyte a day once we really load up and get everything from other teams on board from those other platforms. What's the configuration? What do you mean by that? Like the hardware? So they are physical box 24 core with 256 gigs of RAM, and then 32 gigs is allocated to the heaps.
That's on the hot side.
That's on the hot side, and then those they're matching servers in dev. I mean, in hot and cold, warm and cold. They just don't have
more storage, less memory.
Yeah, more storage, less memory. So if you're talking about like the ratios, they talk a lot about the ratios. We're more like 80 to 1 on the warm cold, and then more like 40 to 1 on the hot nodes. So the ratio that they talk about is really like RAM to disk. You don't want to go above 100 to 1. Like you don't want to have 100 terabytes with only whatever that comes out.
I can't math.
Yeah, 1 terabyte of RAM. So I think the recommendation is right around 20 to 40 gigs, and that's what we've been targeting towards. It's been really challenging because some of our apps will literally ingest maybe 10 events per day, and then other ones are in the millions events per day. And so we have templating to make sure that of those ones that are a little more mean, they're in the 15 shard, they might get 15 shards, whereas everything else gets 3. Has to be divisible by 3 because we have 3 nodes.
We have the Unix team is doing that right now, right?
Yeah, so we have today a version called Grafana, if you're familiar with that. It runs on FluxDB. It's kind of a free thing that it works great, but it only does its one very specific thing. So you have to log into this separate tool to look at it. But we use MetricBeat to kind of pilot against that, and it's done a good job of doing it with the pre-built dashboards and things like that. And if you already have Elk, it's kind of a free thing to add in. Yeah. So I would use MetricBeat. It's pretty good. And install Heartbeat so you can monitor it. No live demo. You're so brave for doing a live demo. I just assumed it wouldn't work, so I'm not even going to try it.
want to hack on somebody's pipeline or something.
Oh no.
I think it's interesting when I hear a lot of the stories. There's always typically one word with there's like a lack of that word, center of excellence.
Are you spoiling?
Fires around. The dead are trying to breach the gates to get into the Elasticsearch. So it's been interesting to see how quickly we guys have come in. Hearing other people.
Yeah. Yeah. Like I said, we have tons of overlap with APM and other things, and it's like one-stop shop has kind of been the driving force. Is like, even if it's only 80% is cool, which it's not, we would still want to use it because it's all in one place, and that has value to us. No, nothing official. Yeah, I went to ElasticCon.
We have a couple of seats, a guy in Costa Rica, a guy in Hungary, but here, just his brain.
Just learn, yeah. I mean, the wikis are good. Let's stick with them. Yeah, it's that easy. Any questions? No? We can all stare at you while you think about it.
That'll help.
All right.